Okay, hello, welcome guys to lecture 17. This is the last lecture of this course, and we are going to deal with another programming language called SQL. You can call it SQL or just SQL or something. Yeah, and this is very brand new stuff from DVC, and it is mainly about doing things like Excel. Like when you're doing Excel, you are making a table, you are analyzing the table data, and SQL is like help you to construct a table within using only codes, and also like there's nothing visually until you finish constructing the table, and also it can help you to analyze that and to filter out stuff and to merge tables and join tables, things like that. So let's get started. So we have three study goals. First one to create a table with SQL and how to select some certain content from a SQL table and how to merge the SQL tables. I also say we have something like about filtering and grouping and merging. Yeah, merging, some people say it is joining, same for me. Yeah, so the first one to construct a SQL table. So I'm providing the interstate map of the United States. And because United States is a country, like everyone has a car so that they can move around. So car culture is spread out and really deeply into the American culture. So I think this example is better for you to understand. We have some famous interstates like 510, 5 and 10 and 80. They are uh, they are passing California. Mhm. So we have to construct a table like that, and we have several columns. Like we have interstate, the numbers of interstates, and the starting point, the ending point, and how long is the interstate. Um, yeah. So this is our raw data, and we're using SQL to construct a table called interstate. So um, the titles of the table. So actually, I mean the names of the columns of the table. Um, so the code is like the first line is create table in the state as. So we're saying, oh, we have to create something. That this is a table, and in the state is the name of the table. And as after as, you have to start putting your raw data into that. So for here, we are having interstate, start, and mouse. So for the first piece of data, we should have uh, the the corresponding specific data for each column. So for the first piece of data, we have 5, we have Seattle, we have San Diego, and we have 1381 miles. So first line, we have to declare, or we have to tell to the computer that um, for the first place, for the first one, it is interstate. For the second one, it is start. For the third one is end. For the fourth one is mouse. And we have to put one piece of one piece of data um, right before the names of the columns. So we have first one. Select 5 as interstate. So the first column is interstate, and 5 is the content at the corresponding place for the first piece of data. Seattle, like because it's a string. For numbers, it's fine, but for strings, you have quotation mark. And Seattle as start, San Diego as end, and 1381 as mouse. And if you only have one piece of data, you don't have a union. Instead, you should end with a semicolon. Um, but because obviously we have, I guess, about 10 pieces of data. So you should have a union. Union means that I have to combine all this together. Like suppose um, those pieces of data um, are like a lot of strings, and you want to combine those strings into a blanket, and you have to use union, like saying, oh, we're doing some sewing work. So you can combine all the strings into a blanket. So we have to use union. For the second row, okay, so the format is select element one from the piece of from the piece of data as column one, the name of the column one, and element two from the piece of data as column two, and element three as column three. Uh, if you are not ending uh, at the first piece of data, you should use the keyword union to combine all the data together. Let's see. Let's see the remaining set of data. Let's see how you program. The second one, select 10, Los Angeles, Jacksonville, 2460. Okay, so for here, let's see, like at the corresponding place, you correspond those data from the second piece of the data to the first piece of data, and you see, oh, 5 and 10 are corresponding to each other. Los Angeles and Seattle, San Diego and Jacksonville, and 1,300 and 2,400. So for here, because you have declared the name of the column from the first piece of data, you don't have to declare them again. You just have to include the content of your second piece of data. And as usual, if you are not ending here, you are not ending at here, you have to add the keyword union. Yeah, union. So let's see. Oh, the third one, select 15, San Diego, Sweetgrass, 41434 union. And we have to combine all this together, and 5, 10, 15, 20, a lot. And then you end at 95. Select 95, Fullerton, Miami, 1924. And you have to use a semicolon to end that, because 95 is the very last piece of data of this table. And we have to finish here. So we just said with a semicolon. Okay. So I guess I have the source code for the table. So this is the source code table. And if you want to see the table, you can always open up the 61A code uh, online interpreter, and you have a SQL interpreter. So just do this. And then the thing is, I want to say select star. Star means all of them. Select star from interstate, semicolon. That is very, it is very like C++. Everything ends at one line. They are ending with a semicolon. So same here as SQL. So we can see the table here. It is sorted by interstate and star and mouse. Okay. So next one. Um, so SQL language is free sensitive to capital letters. Like for other programming languages, I think like Python and Java and C++, they're very sensitive to letters who are maybe some of them are capital and some of them are not capital letters, uh, like uppercase, lowercase. In SQL, uppercase and lowercase of the same letters are treated as the same. So, for example, I can make all of them uppercase, create table, interstate S. And also can have only the first one, like we have proper format, create table, only the initial letter to be uppercase, and also all of them lowercase. Also, you can do something weird, like, oh, I want to have random letters to be uppercase and remaining to be lowercase. It's fine. And they are treated as the same procedure for SQL language. So the next one. Okay, since we have built up the table of a SQL table, and we have to do something interesting to the table, because usually you have a lot of stuff inside the table, and maybe you only want some of them. Like maybe you are setting the range of some numbers, and you only want this range of numbers and the corresponding data, or um, maybe you want to order them, like because some of them are very random and some of them are not ordered as by something that you want to do. So we can have something like filter. We have some keywords. The first one is, the format we have seen. Okay, select star from interstate. Star means everything. Star means the whole table. And we have to use the keyword select and star from interstate. Usually for the star here, it is usually some single columns from this table. If you choose star, that means all columns. So if it turns out to be the whole table, and if you want to only use one column, want to see one column, you can just select start. So you see, oh, this will only display this. You help you to ignore all the remaining data that you don't want. Yeah, because you only selected this column. And select miles, we have this. So the first one, like before that, we are familiar with the format of select something from something, select some columns from a table. And then for here, we use where. Like suppose in the English grammar, I say, I went to some places where there are many homeless. So places, I want to go to some places, and what's special for these places? Um, there are a lot of homeless, so they are selecting some places from the rest of the world, and then because I'm looking for the features of the places of the things I want. The feature is that they have many homeless other than other parts of the world, and then um, so you are having some features and you select them from the remaining things. So for here, because we already know the format of select something from something, and then you have a where at the back, like and then you maybe say, oh, homeless, we maybe homeless greater than 1,000, greater than 10,000 or something. Yeah, number of homeless people greater than something. Yeah. So this is the format when you want to do filtering using where is like you are having some condition, like an if statement or while statement, yeah, for condition evaluation. And then you select star from interstate where miles is greater than 1,500 and miles less than 2,500. And then after doing this, it will help you to select only like star meaning all columns and miles, because I'm having this condition. So miles is greater than less than, and the computer will give me this. So we have 5 interstates. They are like kind of like a middle range, not too long, not too short, and 1,500 to 2,500. Okay, so this is where, and the next one, order by. Order by is to arrange the pieces of data into the table, and then you can try to make them ascending or descending order. So when you want to select star from this day, order by miles, let's say miles, ascending, ASC. So we'll give you this. So it will start from lowest to highest according to the length of the interstates. So we have 55 very short, Chicago to La Place, 964. At the longest is 90 from Seattle to Boston, 3,021. Yeah. So um, Ascending is to arrange that, and you have to declare which column you want to order, so that because for row they would not change places. Like for each element of the row, they are combined together. And when you are ordering mouse, it means that other places. Suppose I'm changing the position of 946 and 1434. So I want to switch these two. When I switch mouse, uh, the the remaining part of the pieces of data will also change places with the mouse. We are not saying, oh, 55 after switch then 55 interstate 55 is like, oh, 400, 1400, and this will never happen. Yeah. So for descending order, we have to use DESC. So okay, so you switch doing the opposite work. So you're using descending. And I have some small tricky question, like select everything by mouse, but I didn't say ascending or descending. So which one is the default? So the default is ascending. Like, so the answer is A. The default is ascending in the SQL language. So this, when you type order by mouse without anything else, it would be ascending. And the next one is limit. Limit is like how many of them will pop up. So suppose I'm selecting star from interstates and I only want the first of two, the first pieces of data of all the table. So um, because by default, we have already a range of them from by the interstate number. So the limit two will be the first two, which will be I5 and I10. Yeah. So limit. Yeah. So by now we have learned about three kinds of filtering. One is where, uh, one is order by, and the third one is limit. So if you want to use all of them together, you have to follow some certain point of format. So format is like select the column you want. This can be as at least one and can be all of them from table. And where you have condition can be more than one, and order by column. I guess column should be only one when you use the column to do order by and column. And then you have to use ascending or descending. If you want to use descending, you have to use descending keyword. If you want to use ascending, that's fine. And also you limit how many numbers of pieces of data you want to see from the computer. So for example, I say select star from interstate where miles is greater than 1,500, order by start. Order by start limit 3. So let's see. Um, for interstate, because by default we arrange all the order of pieces of data using the number of interstate ascending. So we want to have only miles is greater than 1,500. So I guess there will be a very long interstate and ordered by start. Ordered by start. So ordered by the first letter, ordered by the first letter, and the limit is 3. Yeah. So I guess they are using um we have to type that. Mm, let's check it. Okay, I guess I made a mistake here. I guess they're using lexicographic sorting for the strings. So I can show you what a lexicographic order is, sorting is. Suppose lexicographic. Um, so uh, yeah, so if you have an empty string, this will be less than empty strings. This is the first situation. And the second one is if I'm having some certain point of um, strings, and if they're in the same length, they're in the same length, and it will start comparing each of them from the first letter to the last letter until no, actually from the last letter until you find letters different. So suppose A is A, B is B, and we have to use the order, ascending order of the alphabet, English alphabet, because C it comes later than B. So C will be greater than B. C will be because for A and B they are same. For A and B are same. Only at a situation that the length matches and at corresponding places the letters matches they can be equal. Um, for A and B, they are equal. For C and B, C comes uh, later than B, so C will be greater. And for the first situation, if I'm having, uh, if I'm having, I see, when you are having the like first several letters to be the same, and then if if one of the strings is longer than the other string, um, this will be considered as a lambda. So for lambda, it should be less than b. Like lambda comes before a. So this will be less. A is less than ABB. For the fourth one situation. Fourth one is like, suppose I'm having very long string. And yeah, suppose I'm having very long string. So B matches at the first and A does not match. A does not match. I think it's the third one. I can try another example. So suppose both are having uh, the length same. One is like BBA, BBAC. One is like BBC. Um, corresponding places they are same, and A is less than C. So this is less. Yeah, and no matter which string is like lambda comes before everything, and if you're having you and then you for other strings you start comparing from first to the last when you are seeing something different, like you're seeing different letters at a corresponding place. You have to compare which comes before which. Uh, and then if you A comes before B, so A will be less than B. And if you are having comparing some places where there's the string already finishes, so this will be considered as a lambda following following the string. So lambda comes before everything. So the string with shorter will be less than string with greater length. Supposing um, the shorter string is the first letters is the same as the first letters in the row of the greater length. This is lexicographic order. And for here, I guess I made a mistake. This should be ordered by start and then descending, because descending is not default. This is descending, so S before, so S is right after every letter, and E is come later than A. So Seattle will be greater than San Francisco, and S is right after L. So Los Angeles will be less than San Francisco, and I'm comparing start, so that's why. Um, if I'm doing ascending, this will be like that. This will be Master to Wilmington, 40, 70, 35. Because B is before C. Yeah, and C is before D. Although they are having different length, but we are comparing letters from the first one. Yeah. So yeah. So we have to summary, we have three kinds of lexicography. Uh, we are comparing strings using lexicography. One is lambda greater than A. Second one is BB is less than BBC because this is lambda. And the third one is BBBBBC is actually, yeah, it's actually less than BC because we're comparing B and C. So A is less than C. So that's why you see San Francisco is less than Seattle because A is less than E. A comes before E. Okay, so we are going to talk about merge two tables together. Like so far, we only talk about only one table. So we are provided the information of the BART, the subway of the subway system of the SF Bay Area, and we have the information about the bar fare, and we only talk about two lines. One is yellow line, and I set the station start from Concord to the San Francisco airport. And another one is orange line. Orange line is from Richmond to Berryessa, and we can mark them. This is from Concord to, oh, actually from Millbrae and Richmond to Berryessa. So we are doing like that. This is our two examples for this one. Yeah, yellow line from Concord to San Francisco, orange line from Richmond to San Jose. Okay, so we are having, let's talk about this. So station, this is a station name, and the distance means like if I'm taking from Walnut Creek to Concord, and I have to go past two stations. I'm not counting Walnut Creek, but I'm counting Concord. So this will be two. Suppose I'm traveling from Concord to Walnut Creek, say. So I go past Pleasant Hill and I drop myself off at Walnut Creek. So I will have I have two stations, and I count 1 unit of distance by passing uh when you're passing one station. Yeah, suppose Concord to Pleasant Hill is one station because the next station is Walnut Creek from Concord. So the fare is I'm counting when I take the train from Concord to some places along this line, and how much would I pay? Yeah. So let's see from here. You can see some of them are same and some of them kind of weird. Like, oh, San Francisco is $13. Wow, Millbrae is 8.3. San Francisco is like you can take from Concord to Millbrae back and forth, kind of. So yeah. So same for Richmond to Berryessa. And when you are running these two tables, I guess yeah, when you're joining two tables, you have to do a reference from the which table and which table. So for here, I'm having the source code of the two tables for demonstration. So create table yellow line as select Concord as station, 0 as distance, 0 as fare, union. Okay, and then personally one agree Lafayette. So same as orange line, Richmond, El Cerrito, downtown Berkeley. So copy this to here. So okay. So and then we can do our next step. So when updated from OOP, like when you remember Python OOP, you are doing you are having dot product you are having dot operator. Sorry, uh, dot operator. So for dot operator, suppose I'm A is suppose I create a class called A. Let's say age is 1. I'm passing age to create instance, and B is a dog, and I pass in 2 as the instance. Oh, so the dog is 2 years old, cat is 1 year old. So I'm doing A dot life, A dot age is 2, and B dot age is also 2. Yeah. So for the dot operator, they are saying that, oh, the age when I'm saying a dot age, I'm saying I'm referring to the age of the cat, the age of the A, and for B dot age is like the age of B. Yeah. Oh, this is 1. So it's the same as in SQL language, because when you are joining tables, because I want to combine these tables together, but I'm merging. So we actually don't know which table is which is Concord, which table is Richmond. So you have to know that. So update it from OOP, and I'm writing this code. So select A.station as a common station. Like I'm saying the station that shared by two lines, the yellow line and the orange line, and A.station as common station. And A.fare is the fare from Conquer, like because they are sharing stations, which means that which means that um I can take a train from Concord and I can reach this station, or I can take a train to from Richmond to this station. They can both reach this station. But I'm saying, oh, because I'm having the column called fare from the table Concord and the same name from the table Richmond. When you are saying fare, when you're only saying fare, you actually like the computer actually don't know which column you're referring to because I'm having two columns, so this will be ambiguous. So I have to say A.fare as fare from Concord and B.fare as fare from Richmond from two tables. One is yellow line, one is orange line, and I can make it a nickname. And then when I say nickname, it's like I'm referring yellow line. I'm referring like because for A it's actually um referring to yellow line, and from yellow line as A, I'm making like the official name of yellow line is just yellow line, and the nickname is A. So A is now equals to yellow line and also orange line. So I'm making a nickname or Ellie, I guess. Yeah, I'm making a different name, a simple name, so I can use that to refer to the table that I want. Or you don't have to like some situations like you think I'm taking one more step, so you can just ignore it. You say yellow line dot fare and orange line dot fare. And this is the tables, or table A, table B. A is referring to yellow, B is referring to orange. And the last part is where. So where is having a condition because I want to have a common station. So A dot station will be equal to B dot station. For here, for SQL, because for SQL we don't have to do the assignment. We don't have to do declaring, initializing. So the equal here is just equal. It's just same as A dot station and B dot station. And so because A dot station and B dot station will be the same and will be the same, so we can only use one A dot station because we don't have to use B dot station. Or maybe we can change A to B because they will be the same though. So after doing this, you will have the code like this, common station, uh, and fare from Concord, fare from Richmond, and you have 12th Street, Oakland, 19th Street, Oakland, and MacArthur. So it's the fares below. Okay. So when you break down into pieces, you will see how clear that is. So select something as something, something as something. So you're actually selecting different columns from different tables, different columns from different tables. And then um, because because we have seen like the things like the name of the column like station and fare, they're actually same. So you have to do referring. You have to refer, oh, when I'm saying this fare, I'm saying the fare from Concord, and I saying that fare. That fare is actually referring from where I'm taking the train from Richmond. So you're setting columns, and then they when they're different, when maybe you want to have to rename them. Yeah, they're different. So this is selecting, and this is remain a rename. So in the new table, there will be a brand new name of column, and from two tables. and you have to make references or source table. You can change their names, and you can also don't have to do that. Yeah, so you can either change name or not. And where A station is middle station is the condition that you want to filter out. You only want to have the common stations between A and between the two lines. So you're just applying filtering on tables. You can do double equal sign, but single equal sign and double equal sign is equivalent in the SQL language. Okay, I'm doing merge. And you have to avoid column collisions. What is column collisions? Column collisions is just, for here, I'm having fair from Conquer, bit of fair from Richmond. I already do the reference of the fair from Richmond. So this will be fine. But for fair, when I'm doing this, for fair from Conquer, I'm having error because in ambiguous column name. Like because I'm having two columns, each from different table, and the name of the columns is they are the same. So for the computer, it does not know which column you are trying to say. You are trying to refer to. So you have to use A dot fair. Or if you don't like A, you can say yellow line dot fair. So this can help you to distinguish which column you are actually want to use. So okay, this is bad. And the next one is aggregation. Aggregation of tables. So you usually want to doing something like to count. These are the five basic functions of aggregation. We have done that in recursion and while loop list or something like that. So same as in SQL. So when you're counting on numbers of them. Numbers, yeah. When doing sum, you are summing that up. Doing average, you are summing that up and divided by count. I think, yeah. Maximum, choose the maximum from among. Minimum, choose minimum from among. Yeah. Same as in Python. So let's see, select average of distance, and as average distance, select average of fair as average of fair. So from yellow line, yeah. So I calculate that, it's already been table, because for average of distance and average of distance and average of fair, like you are counting all of them. So so there will be only one piece of data because you're doing all of them together. So you only have one output for each of the column. So you only have one piece of data. Yep. And the next one, I want to talk about group by. Group by is where to apply aggregation function. What is that? Okay. When you are going to do aggregation function, you have to use group by. Yeah. So group by is like, I guess, it's more like clustering, more like analysis. So when you select fair and count star from yellow line and group by fair, order by fair. So when you are doing this, because we have to draw a table, we have the station name, station, say Conquer, Pleasant Hill, Walnut Creek, and then you have distance, say in 0, 1, 2, and you're having the fair. So this 0, suppose this is 2 and 3. Yeah. So so as you see, I actually have more example. W and Lafayette and Orinda. So suppose for Walnut Creek and Lafayette, I'm having the same money cost, and Orinda I have to add by 1. So this is 3 and 4. 4. And for that situation, when I'm doing group by, I'm actually just looking at the fare, and then I want to cluster those pieces of data into a single table. When you are like, I'm actually want to this table, but actually decompose this table. Oh, I have a table of 5 members. So by clustering, um, for each one, I will only look for when I group by fare, I'm only look for the pieces of data that are having the same fare, and then I'll clustering them and make them to a new table. And for the remaining part, I will see if if one is equal, having the same fare as another. So if not, they will say goodbye to each other, and then they go to two different tables. And so I'm actually doing subtraction, I guess. So for this table, when I'm doing group by, I'm actually having, I guess, 1, 2, 3, 4, 4 new small tables. So one is Conquer, 0, 0, and one is Present Hill, 1, 2, and one is Walnut Creek and also Lafayette. This will be a new table, 2, 3, and this is 3, 3. So the last table will be Orinda, so 4, 4. Yeah, I'm 1, 2, 3, 4. I'm decomposing these tables into different small tables, and this is good group by. So you're doing clustering. So let me think about AI. For AI, um, when you are like provided some data, and you are having some, I guess you're having some inputs. And for this clustering kind of algorithm, you don't actually have to analyze them. You just have to group them according to some certain condition. Once they are the same, you just clustering them together. And when the other thing same and different from this, and they will be clustering to here. So it's more like when I'm having lots of data points and some of them having the same attribute. So I will clustering them. I'm decomposing the whole. Yeah. So that means break table into pieces. Um, yeah. Okay. So I just have done with group by, and I want to select fare, like how much is like 2.3555 something. And we have to count how many members in these small tables. So for 0, only conquer. So 2.3 from the original table, this will be 4 stations. Yeah, so I'm counting 4. And I put 4 here. So 4.55, 175, 3. So I'm counting, like from a small table, I'm counting how many members inside. So once I get that, I will, once I get how many members, say this 2, so I will get be with to be with the fare, to be with the corresponding fare. So when the last step is like order by fare. So since I'm having this data, and some of them may 2 comes before 4, or maybe 6 comes before 4. So I'm making the ascending. I say, oh, 2, 4, 6. It's not 2, 6, 4. So okay. So this is what I'm doing. So I guess I can have some example. Okay. So can step style, step view. Where I'm having this. This is the original table, and I want to decompose them according to the fare. So for these 2 stations, they are having the same fare, having only Concord should have the 0. Yeah, I'm actually still not clustering. So I will still have that. Okay, so I'm decomposing the tables. Yeah. So I'll have 3 stations with the fare of 475, 1 with 0, 1 with 2.7.4, and 3 6.85. 4 of 3, 2.3. Yeah, so I'm decomposing table and group all the data as long as they are sharing the same fare. So the next step is like, oh, I have to count how many. Here's three, here's one, and here's three, and here's four. So I'm counting them. So I put them into the data table. And for here, I also want to do order by, but since it's already okay, so it's just okay. When I'm doing ascending, this will be different. So yeah. So I guess I can have step by step. No, fine. So, mm, so having must be used by group by, but having is same as where. Having is same as where. Okay, it's equal to where. It's more like when you're having the you're having like you're having the Clipper car in San Francisco Bay Area, and you're having the Metro car in Los Angeles. You can use them to take subways and take buses, but they are having the same function, but they are serving in different area. So this is the difference between having and where. They are essentially they are same, but they are using in different situation. They're using in different field. For area is default, I guess. Is default. Is for some simple doing stuff. But for having, you have to use group by. So because group by is like to decompose the table and make all the to make pieces of data to be clustered according to fare for here for this instance according to same fare. And for having is like when I'm having some small tables, I have to do filtering. I have to throw out some I have to abandon some data that I don't want. And for here, I have to do that according to distance. When I'm doing distance is less than 10. So I'm only giving the distance less than 10. So in other words, I'm abandoning the distance is greater than or equal to 10. So from here, uh near uh okay. I lost comma. So I'm having this table and I'm decomposing them. And then I want to do this part, having distance less than 10. So next step, um, for the green here, it shows that it is satisfying the condition of distance is less than 10. So for other table, it will be abandoned. It will be thrown out into the trash can. So I'm only keeping this, and then I will do counting and do maximum from the remaining tables. Yeah. So I'm just having this like for the count is a way less than the counts of fair. So yeah, this makes sense. So because I'm having. So if you want to use all of the keywords, you must follow this format. So select column one, column two, something else until you're getting a star. Yeah, and you select all of them. You only have to use a star. And from table one, table two, and you do reference. When you are doing nickname, you're doing at this part. You're doing nickname, doing alternative name. Suppose low line as A, low line as C. Yeah. And for where, you are having condition, and condition can be more than one as long as you're using and or like and or operator, some logical operator. I didn't mention that. So, and or then condition 2 and or condition 3 dot dot dot. Okay, and then you group by the column. Yeah, you group by according to column, like as long as they're sharing the same information in this column, they will be grouped together and become a smaller table. Yeah, and then when you are having is like you have to throw away some unnecessary tables or some pieces of data in the small tables when you are doing having. Yeah, and then when you throw out, you can have the table satisfying some small tables satisfying group by and having, and then you do order by. So for order by, oh, okay, I guess you are having group or having. I think you may be doing aggregation, things like counting how many members in a single small table, things like that, or you finding the maximum minimum, and then you throw this when you're doing an aggregation. You are throwing that to this column, I think, yeah. And then you do order by, yeah, order by the result of the column, like according to which one you want, and then you will do ascending, descending. Like by default is ascending. Descending is the default, and you have to do limit of how many numbers I want to pop out. Things like 1, 2, you can choose from 1 to the size n. Yeah, if you want to, if there's an n size of table, the table with size of n, you don't have to use limit. Yeah, because it will show everything up. And for more about SQL, you can use this website. You can see many other stuff of SQL, and for this course, it's only the introduction. Okay, so hopefully this is the last page of the slide, and hopefully you enjoy my course, enjoy my lectures. Although it's kind of long, yeah, but I guess you can learn a lot. So uh, hopefully you can have a rest of the day, have a very good summer, and if you are trying to take introductory computer science course, wish you good luck. And yeah, this role is tough, but is of a lot of fun. Yeah. So hopefully you learned a lot during this lecture, and goodbye. Goodbye. Have you have a promising future. Goodbye. Yeah. So